Welcome everyone to week 8 of the research methods, and this week we're taking a look at analyzing the data and just getting some ideas. Granted, there's no way that this course can teach you everything, especially since we really only have 10 weeks to go through all the different aspects of research. So really today we're just kind of getting a sense of kind of some of the ideas behind analyzing data. And I guess the most important thing I could say right off the bat is that regardless of which way you decide to go, qualitative or quantitative or potentially both, make sure you do your homework, do your research, talk to people, and go from there, because this at most will give you a sense of maybe some of the things you need to look at, some of the things you need to understand before you get knee-deep in the data and realize that hopefully you haven't gone too far that you're in trouble. Alright, anyways, today talking as per usual, few things in the news, and then just a brief intro about analyzing the data, talking about quantitative analyses, and then qualitative analyses. Alright, in the news, Venice underwater. Don't know if you guys have seen recently, but there's been some news stories about the rising water levels in Venice, and the fact that the water levels, I guess globally, are rising too fast for Venice to keep up with. And there had been some plans to put up some dikes and things like that, but due to funding issues and cutbacks and things like that, these dikes that were supposed to be ready by 2013, now they're talking about 2015 or 2016. So could be a lot of things happening to Venice over the next couple of years, and some real damage. And discussion about what's that caused by and gonna occur. Next, new/old marketing agency announced for British Columbia. Again, in case you guys haven't picked up or heard this, Destination BC is being created. I guess to replace the past defunct Tourism BC, and how it's going to work, the funding, who's actually going to be managing it, all of that sort of details are yet to be announced. So basically it was just an announcement of something being created for next year. I guess partly depending upon what happens with future elections and things like that. So I guess stay tuned. And finally, Boeing ups production of the 787 Dreamliner. At this point, they're producing nearly 5 planes per month, which when it comes to jet airline production, that's actually pretty good. Although they're actually hoping for much better production in the not too distant future to hit some of their production targets that they have set. Now, one of the reasons why, those of you that know me, that I love talking about the Dreamliner is that I think it was a real step forward for the airline industry or airline producers. The advancements that came along with the 787 or that are coming along, carbon fiber production, much quieter engines, fuel reduction, fuel savings. It's quite an amazing plane. Bigger windows, better humidity levels within the plane, better pressurization levels within the plane. All sorts of things that have been brought in. It's not the biggest plane, but it's got some of the biggest potential, I think, for the airline industry now and into the future. So, again, keep an eye. Just wanted to point out, though, if you take a look at the picture there of the Boeing 787 as it's coming in for a landing, you can see how the wings have actually, they bend upwards. And that's because of the carbon fiber that's in the wings. And it might be a little disconcerting at first, but it's just one of the things about the plane that, one of the unique characteristics of it. So, if any of you ever get the opportunity to fly on a 787, go for it. All right. Anyways, introduction to analyses. Now, not surprising, qualitative and quantitative information, while there's can be a bit of overlap between the two, generally most of the techniques that you will use for one are not transferable to the other. So, they're complementary, but they're separate ideas. Now, it's a good idea, as we've talked about before, to combine the two into a bit of a mixed methods research, but that isn't always the case, and that's not always required. So it just, again, depends on your research questions. So just some very quick starting comments, I guess, about quantitative and then qualitative, and then we'll dive in a little bit deeper on the quantitative aspects. If you're going to go quantitative analyses, especially if you plan on using any computer software packages, and there's quite a few out there. Personally, I prefer working with SPSS, but there's SAS, there's all sorts of others. You can even do some of your statistical analyses with things like, Excel. But it's important that you understand, I guess, the theories behind the statistics before you start using these computer programs, because these programs can provide you with all sorts of, terrific analyses and graphs and charts and things like that. But if you've applied the ideas incorrectly, you may come up with incorrect assumptions and conclusions about your information. So, just because you can run an analysis with these computer programs doesn't mean that it's the right analysis to run. Same with qualitative analyses. There's really no one accepted method when it comes to qualitative analyses. There's several different ways you can look at it, and we'll talk about a few of them today. But, I like qualitative information because it really helps to, I guess, bring life and some real meaning behind some of the hard data. But before you go into it, get help. If you're not experienced with doing qualitative or quantitative analyses, get help before you start, before you get into it, so that you get things right from the start. And if you're going to seek help from somebody who's experienced with qualitative research if you're looking at qualitative information, or quantitative research if you're looking at quantitative data. Because just because somebody's an experienced researcher, if they haven't worked with your type of data that you're interested in, their experience may not be that useful to you. Okay? So, just that kind of word of caution before you get too deep into your analyses or into your developing of your research. Now, quantitative analyses. And again, just a very brief introduction into some of this. You really need, and this kind of came out in the assignment too, you really need to be thinking about your analysis when you're designing your research. When you're first putting things together, before you start collecting the data, that's when you really need to be thinking about what you're going to be doing with your data, how you're going to analyze it, how you're going to put it into the whole system. Because otherwise, you may get to the analysis stage and realize that you've missed something or collected something incorrectly or created a whole lot of extra work for yourself. So think about it right from the start. Lots of different ways to enter the data. You can sometimes import it directly, enter it. You can manually enter it yourself. There's computer programs and I guess systems that allow you to scan. You can have scannable forms. You can even have the data going straight into it through things like SurveyMonkey and that. But whatever way you choose to enter your data, make sure that you're minimizing the potential for error. So the less times you have to touch the data before it's in your data set, the better. Think about making it as easy as possible for yourself. And again, that kind of also comes back to the whole minimizing the potential for error. Because the easier it is for you to enter the data, the less likely it is that you're going to make mistakes when you're entering it. And as you're putting the data in, think about how you're going to analyze it. Think about all the different ways. I'll give you a possible example of that. It might be very simple to create categories for something like age, or years of education, or number of trips that somebody has taken. But once you've created a category, you can never go back to that original data. Or if once somebody has entered a category, you can't go back to them afterwards and go, oh, by the way, have you how many trips did you actually take? Which year were you actually born? Things like that. Sorry, the girls are barking at some people that had the nerve to walk past with their dog. Anyways, so, my point is, you're better off, where possible, to, have the person give either their birth year, if you're collecting age. You can make the conversion and then you make the groupings afterwards. Or ask them the number of trips that they've taken rather than getting them to fill out, which category number of trips. And then you can slice and dice the data afterwards how you see fit. Okay? Typical way for your data records to look when you're doing quantitative, in your data record, is that each row, if you can think of your spreadsheets like Excel and things like that, each row is generally considered to be a single respondent. So row 1 is respondent 1, blah, 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 things like that. And each column is your variable. So, maybe column 1 is their name, and column 2 is their age, things like that. So that's a typical way of looking at a data set. When you're thinking about missing data, somebody fills out the form, they complete your SurveyMonkey survey, and they decided to skip a couple of questions. I guess first off, try to minimize that skipping as much as possible without being annoying. So any questions that are, for example, any questions that are absolutely necessary, make sure that they are required questions with SurveyMonkey, which you can set up. But if it's not absolutely required, then sometimes you can let some of them go. Now, if somebody hasn't completed some of the questions, generally you want to think of that data as being a non-response. And a non-response is not the same as a don't know or not applicable. So, it's good to provide sometimes with some questions a don't know or not applicable option, but you can't consider when somebody has left a response out, when they leave a response out, you don't know what they were thinking. So you cannot assume that it is a don't know or not applicable. And there is a difference. Before you start your analysis, always give yourself a little bit of time to clean the data. And cleaning the data just means going through and understanding, or looking through it, seeing if there's any errors in the data, any numbers that don't really make sense. An example, someone might be entering their birth year and they've entered a number that's not possible. Maybe they were born in 1982 and they only wrote down 982. You can probably assume with some of that, by looking at it, sometimes you can guess what the proper data should have been. Sometimes when somebody enters a number, they might put a decimal, an extra mark in there. And the reason why you want to clean up all this data before you start your analysis is because all of these little bad bits of data will just get in the way of your analysis, and it can eliminate some of your information, especially if it's just a simple error. However, when incomplete, if you're not sure at all about what the information should have been, if a number, for example, a birth year, looks completely, impossible, and you know that it should be impossible, but you don't know what the proper one should be, some of the times that data, you just have to delete it. Get rid of it, get it out of the way so that it doesn't mess up with further analyses. A lot of your data, a lot of your analyses tend to be separated into kind of either exploratory, just seeing what the data can tell you, giving you a little bit of understanding what the situation is, or confirmatory, kind of explanatory data, where you're trying to determine something, you're trying to figure something out. Frequently, your confirmatory data is associated with those sort of fixed design research, where you knew most of the situation going in, things were fairly set right from the start, and so all your data and your variables and everything are fairly clear. Okay, so you've kind of got those two different ways of looking at your data sets. Something else that you're going to hear, and you probably have heard before when you've heard about poll research and things like that, is something called statistical significance. And margin of error, confidence levels, things like that. Statistical significance really talks about, whether or not there's a bit of an actual difference and a proven difference between generally what's considered two populations, two or more populations. And what you're testing, or what you're doing with this statistical significance, is testing what's called the null hypothesis. Now, There's a lot to understand with null hypothesis, but essentially a null hypothesis says that your two populations are not different, or there's not enough difference between them that you can say with any certainty that they're different. You know, you might be looking at males and females and the number of accidents that they have driving and come up with, maybe, you came up with a different in percentages, but because of statistical significance, that difference in percentages isn't large enough for you to say one way or another about your hypothesis. That's what the null hypothesis is all about. And it's important to understand when you're thinking about statistical significance that something may have a statistical significance, but it may not be an important difference. And by that, when I'm talking about important difference, it all comes back to, what we've talked about before with real world research and making use of research. And saying that, if you're not going to do anything different with the information, if it's not going to make any difference on your managerial decisions, then that statistical significance is not an important difference. Again, coming back to kind of that earlier example, you may find a statistical significance between males and females and the number of accidents that they have. But, regardless of that sort of information, if you're going to send the same information out to both males and females about the importance of driving safely, or maybe the importance of having insurance or whatever, it really doesn't matter what that statistical significance was. So this is where it comes down to reality versus statistical significance and researcher significance. Okay? So just think about, I guess, the real importance of your information before you get too hung up on statistical significance. When you start looking at your data set, lots of different things to understand and ways to look at it. Your frequency distributions show you all sorts of percentages and numbers and things like that. So there's a lot to understand. There's a lot of really good books out there that can tell you how to interpret some of your data, some of your data sets, some of, the statistics that you can discover. Everything from statistics for dummies to statistics in a nutshell and all sorts of things. So I'm just going to cover a few, I guess, very, fundamental concepts with statistics and with your data. First off, something called location or central tendency. And three important terms to understand: mean, median, and mode. Mean is the arithmetic average of responses. We've all done or heard of averages or means. Add everything up, divide by the number of data points, and that's your mean, your average. Median is different. Median, what you do is you put all of your numbers in order, largest to smallest, smallest to largest, whatever, and you find the middle point in all the data. And if it happens to be an even number of data bits, then your middle point is actually between those 2 points. Okay? Your mode is the most frequently occurring response. So it might be something completely different than your mean and your median. And in fact, all three of these can be completely different from each other depending upon what your data set looks like. The mode just means that more people have chosen that response than anything else. And because of that, depending upon how many possible responses there can be more than one mode. So it's important to understand that. Now, you use mean, median, and mode for different things, different types of data, things like that. So again, important to understand data, your data set, what your purposes are, and how you're planning on using it. Next, I guess, important category of descriptive statistics is the measure of spread, variability, or dispersion. Basically, how spread out is your data. And variance is something called the average of the squared deviation scores from the mean. Basically, variance takes the mean and then it compares how far from that mean every bit of data is and creates a value. And the larger the variance is, that means the bigger the variation is between your average and all of your data points. The standard deviation takes a positive square root of the variance. So it's just another way of looking at that variation. Again, the larger your standard deviation is, the larger the variation, the more spread out all of your data is. And range, of course, everyone has heard of range. That's just how much from the smallest to the largest number. Okay, so that all gives you an idea of how spread out your numbers are. The shape of the data also kind of talks about how spread out all of your numbers are, but in a bit more of a graphical point of view or perspective. Skewness, I guess to take a quick step back, if any of you have ever heard of a bell curve for data, it's when your data looks like your typical old-fashioned bell with a bit of a lip at the bottom, peaks up to the top and then comes back down, and a nice lip on the bottom side again. When that shape is completely symmetrical or completely even, then your skewness is very low. Basically, the more something is skewed, the more one side or the other side of that shape has been pulled out. So, for example, you might talk about the data being skewed to the left. That means that tail, that initial part that's touching the bottom of your graph, is spread out more to the left. If your data is skewed to the right, then that tail stretches out further on the right-hand side. And the more it's pulled one way or the other, that means that your data is less even and less symmetrical. Kurtosis looks at a little different aspect of the data, and it talks about how flat or sharp your data is, which essentially says whether or not your data is more centered around your mean or spread out more across your entire data set. Okay? Again, best to look at some examples in the book or online to get a sense of what I'm talking about when I'm talking about kurtosis, and skewness. Outliers. Outliers is another term you might hear, and that's just little bits of data that don't look like they make sense or are completely out of place when compared to everything else. And sometimes your outliers are important because you need to be aware of them so that they don't mess up and cause problems for your data analysis. What can happen, for example, you're taking a look at people's income, and suddenly somebody, decides to say that, hey, I'm earning $1 million a year. Well, if you were to leave that information in your data set, that could cause real problems with your analysis. So, just something to remember and something to watch out for. Sorry about that. Now, when you're looking at relationships, one thing to consider is, something called a crosstab or a cross-tabulation, where your data will actually get put together into kind of a typical table format that you've probably seen before. And for example, down one side, you might have one category of responses, and down another, across the top, you've got another set of type of response, another set of variables. And the idea behind the crosstab is to give you in a very simple table format just a way to compare two or more populations or groups. Again, coming back to that earlier example, you might have male and female across the top of your table and number of accidents in the past year down the side. And just a way for you to look at the information and to make comparisons between groups. A chi-square test takes that crosstab or those sort of relationship linkage and goes a little bit further to talk about how strong of a relationship there is between two variables, and to try to understand whether or not that relationship is due to chance or if there's a real statistically significant relationship that has occurred between your variables. Now, I guess the important point at this point to mention is just because there's a relationship there, there's a correlation there, there isn't necessarily a causation. So, you may see a bit of a relationship between two variables, but you can't say that one thing has caused the other because they might just be randomly occurring together, or there might be a third factor that you haven't even discovered yet that's causing both of them. So, again, be careful how you analyze and interpret your information. A scattergram is another way to take a look at these relationships, and it's essentially just like a diagram showing all the data set and the data points, and it can show you in a graphical format how your different data is related to each other. I guess the more precise, the closer together your scattergram is, the stronger that relationship is. The more spread out across the whole graph, then the less of a strong relationship you have between your variables. And correlation coefficients, finally, it's another way of measuring and showing the strength and the nature of the relationship. And with correlation coefficients, they run from a -1, which would be considered a perfectly negative relationship. For example, when one goes up, the other goes down, to a +1, where it's a perfectly positive relationship, so when one goes up, the other one goes up. Now, it's very rare that you're going to have something that's perfectly positive or perfectly negative, but those are kind of your two extremes. And so your 0 point between them means that there's no relationship whatsoever. So that's your middle point. Just one last quick thing on statistics and, I guess, quant information. I love a lot of the Dilbert cartoons, and this one, a little bit about, takes a little shot at statistics. Give you a moment to read through it. And then next we're going to talk about qualitative research and just some ways to look at qualitative information. All right, qualitative analyses, getting a feel for your data. One of the issues with humans analyzing qualitative data, or I guess some of the issues, is that, especially for most people, there are limits to what we can do, what we can deal with, what we can process. So you've got real issues, I guess, to start off with something called data overload. And especially when it comes to qualitative data, qualitative information, because it's not using numbers, because it tends to not be being grouped into little bite-sized pieces necessarily, you can run into a real issue with data overload. Qualitative data also can run into an issue of this constant hypothesis revising. So, you start it with one idea, and then you get a bit more information, so you change your idea, and you go into something else, and then you go to something else again, and popping back and forth as each new bit of information comes in. And that's why it's very important to just keep an open mind and not come to any conclusions before you've collected all your information. You can have real inconsistency, more so with qualitative than quantitative information, but it can occur with quantitative as well. But real inconsistency in how you interpret the data. Because it's very qualitative, because qualitative information rarely has a black or white sort of answer, just shades of gray, different people can look at the same qualitative information and come up with different conclusions. As well, and this can happen with anybody, becoming overconfident, becoming too sure, too confident of your abilities and coming across too much qualitative information, or maybe some qualitative data that you've never dealt with before. So, one of those sort of humbling experiences. And finally, biases and preconceptions. And this is something that I've mentioned to a few of you already. And just the importance of remaining as objective as possible right from the start. Now, this can be more of an issue with qualitative information because the whole idea of, there not being a black or white answer, and if you're coming into it with a preconception or pre-notions of what you're going to see, then your mind starts selectively choosing the bits of information, or it can selectively choose the bits of information that help support your ideas, and you start to ignore anything that goes against, or you discount it. You say, oh, that's just a one-off, and you can run into real issues there. So, important to remain objective throughout the entire process. A few different types or ways of looking at qualitative research. Kind of a quasi-statistical, and more than likely using a computer for this sort of thing, where you've done a content analysis and possibly even the computer has done most of that work for you. So you're essentially doing frequencies and correlations and things like that. Maybe the computer has chosen keywords and the frequency that those keywords are used. So, trying to apply some statistical analyses to the process. A template approach where you've probably set up kind of codes before you've gone into the process, and as soon as those codes or those situations have occurred, you've ticked them off. You've put that response, that qualitative situation, into that bin. And that can be another way of looking at qualitative information. Sometimes maybe you haven't done a code to begin with and you've stayed fairly open, but once you've got some of the information, like a grounded theory approach, you start to create some theories and some ideas and some relationships. So you develop those codes once you're into the process. So, a much more flexible way of approaching the whole analysis of the qualitative data. And finally, an immersion approach. And this is probably the most difficult and requiring the most experience by the qualitative researcher. And this is where it's more or less a sort of profiling approach, where you just absorb and try to get into the data. Try to immerse yourself and become as much a part of the data and let it more or less kind of speak to you. Again, very difficult to do, especially, like we've just already talked about. If you get too much data, there can be this whole data overload, and you start to lose perspective or lose some of the bits of information. Quite often, qualitative research will typically have some coding of the observations, some material. Possibly you've added some comments about, your understanding, what you've seen, what you've heard, things like that. There's always a bit of, looking for phrases and patterns and certain things that keep occurring. Trying to group things together and forming some sort of generalizations under themes and categories, things like that. And especially if you're working within a body of knowledge or some theories, trying to link what you've seen with your qualitative information back to the theory and seeing how well the two of them link and flow with each other. Lately, computers have become, much more useful and much more prevalent in assisting with not only quantitative analyses but also qualitative analyses. And some people have actually come up with some computer programs that will assist in qualitative analyses, but even word processors can help with some of these sort of qualitative analyses. Things like that find can give you word counts, get keyword phrases, things like that. Even just setting up a spreadsheet where you've categorized some sorts of things can assist in, use the computers for assisting in qualitative analyses. Some advantages of using some of these programs is that, to begin with, you've got all of your qualitative information in a single location. Can sometimes give you a little bit more of an objective look at your information, especially with some of the more advanced computer programs that are out there. These computer programs, like all computers nowadays, are able to handle much larger quantities of data. So where there used to be limitations before on some of these sort of content analyses and other things like that, computers are increasing the boundaries and pushing that. And it can also help in being a bit more consistent in your coding system. Now, some disadvantages, though, is that to get really good at using your computer for qualitative data, it can be even more difficult and take more time and effort than some of the quantitative analyses. Another big issue that you can run into with using computers is because people assume that computers are much more objective and, much more reliable at times, there can be a real resistance to changing some of your categories. There can be this sort of blind trust that, it was done by computer, it must be objective. And sometimes that sort of what I call blind faith isn't always justified. The computer may not understand the sort of contexts, or you may, skip over some of the context when you're doing some of your categories if you're simply using the computer trying to be too objective with it. So, use computers with a bit of a grain of salt, and how you use them in your analyses. Some ways of looking at qualitative data. The text talks about Miles and Huberman approach, and just a bit of a framework for putting together qualitative research. Note that it's especially useful for case studies. And, it's trying to look at not just, documenting a situation, but actually describing the situation, looking at causation, looking at relationships, things like that. And really trying to understand some of the whys about what's happening, not just the what. Some of the key things or key ways or key aspects of it is reducing some of your data into some key activities, key aspects, key behaviors that you're looking at. Developing some sort of display, usually visual display of the relationships, things like that. Building a bit of a network. And really developing and refining your assumptions and your theories and your model of these relationships. So, again, this is just one way or one method to look at qualitative information. When you're trying to generate some meaning with your qualitative information, lots of different ways that you try to reduce your data into some meaningful bits of information. You'll quite often do things like clustering of the data into things with common meaning. For example, if you're taking a look at the image of a place and you take all the words and you break them down to maybe positive images and negative images, and even under that you might go positive feelings and positive positive pictures and positive activities, and similar on the negative side. So it's just a matter of grouping them into these sort of meaningful clusters. Qualitative, you might be looking at the frequency of key events, the number of times somebody has done something, the number of times somebody has stopped and read the sign. That might be the the qualitative bit of information that you're taking a look at. You might be trying to build kind of a logical chain of events. This occurs, then this occurs, then this occurs, when you're getting this qualitative data together. And finally, you might be doing some sort of contrasts and comparisons between how your different populations approach a situation. It really all depends on what your data is all about and the type of research that you're working on, how you're going to group things together. So it's really difficult, but again, these are some of the sorts of things you need to be thinking about before you get into collecting the data, thinking about how you're going to analyze and possibly group things once you've got things collected. Now, if you're wanting to assess how good your information is, or what the quality of your analysis, quality of your information is, lots of different ways to do that. Things like triangulation, and triangulation, as Timon has mentioned in our discussions, there's lots of different ways to think about triangulation. And that could be, comparing what you've discovered with your qualitative research to what other researchers have discovered, and do they make sense? It may be comparing your qualitative information with some quantitative and seeing whether or not different conclusions are being reached. Or it could be getting somebody else to do the work and seeing whether or not they come to the same conclusions that you do. So, other things you can do to assess the quality, taking a look at outliers and why those outliers might have occurred. Now, I don't know if you guys remember, thinking way back when we were talking about collecting qualitative and quantitative data and talking about the importance of keeping a diary. And sometimes that diary can help you explain those outliers. That diary can say, the reason why you got some really bizarre data that day is because some particular, event occurred that day that really threw things out of whack. Okay? So that really talks to that importance of having that diary when you're collecting your research. And, Sometimes it's good, especially with qualitative data, to put up some alternative explanations and test them to see whether or not they're valid. Okay, so lots of different ways that you can check to see whether or not your conclusions are good. Again, coming back, grounded theory analysis. That's where, as a quick reminder, grounded theory analysis or grounded theory is when you've approached the situation and you haven't come in with a theory to begin with, so you're kind of letting the data create the theory. And there's three main stages to it. You find some conceptual categories, some groupings, some ideas that you can put your different bits of qualitative information into. Then you start to look at relationships between those groupings. And finally, you come up with some ideas, some theories, some hypotheses to help explain those relationships. But again, with grounded theory, all of that comes after you've collected the information, not beforehand. So, now, three possible ways to code with grounded theory. Completely open coding, and that's where you're just splitting up into, major categories and just trying to interpret the data. This would be, kind of more when you're just being immersed in the data. Axial coding, where some of those codings, from those categories from that open coding, you try to start to link them together, start to create some of those relationships, and developing some of these models, themes, these theories, hypotheses. And then finally, selective coding, where you try to create one sort of core category that you focus in on. And that becomes kind of that central pillar that your grounded theory is based on. So, different ways of, again, trying to group and understand and interpret your data. Finally, I know it's been a long presentation, but just some quick final thoughts. And again, some of this is just based on past years. Don't be afraid to try something new and push yourself. Some of the people in the past felt they were more comfortable with qualitative or quantitative, but they realized that the qualitative or quantitative ideas were really where they needed to go. So they tried something that they weren't comfortable with necessarily from the past and got some really good information. Again, before you get into any of this, there's always somebody around to help. So just ask. Before you get into your analysis, do your homework. Do your theory, do your literature reviews, everything like that. The more of that background work that you've done beforehand, the fewer errors and stresses you're going to have after the fact. And never rely on just one reference, one source for any of this sort of stuff, including doing up your research methods. For example, we've been using Robson in this course as kind of that central book or central text for a lot of the ideas, but there's a lot of other sources out there. Use them, especially once you start heading down a path of a certain type of analysis. Then start seeking out other sources of information along that path. And that final reminder, Let the research question guide the research method, not vice versa. Don't go in with an idea that you're going to conduct a survey or you're going to do a focus group. Figure out what your research question, your research problem is, and then determine what's the best way to gather that information, okay? And you'll always come up with a better result that way. All right, thank you very much, guys, and thanks for sticking through to the end. All right, bye.